left part, and since the horizon is the line that I'm pointing at with the mouse, you can see it there. Completely opposite that is the southern horizon to the right side of the diagram. And into the paper, or into the screen, is east. Because if I'm facing north and I turn to the right, in this case into the screen, that would be east, and out of the screen, or out of the paper, would be west. Alright, let me give you some help with this. I'm switching over to a computer view. So here is a celestial sphere, and what I can do with it is I can rotate it around. You can see that the Earth is inside. The blue lines coming out of the celestial sphere represent the north celestial pole and the south celestial pole. I can rotate this around and you see that there's a white dot on the Earth. That white dot represents somebody's location on the surface. I could change the latitude so that I could be at the equator, I could be at the South Pole or in Australia, or I could be somewhere, say, in the Northern Hemisphere, like Western Europe, or I could be completely at the North Pole of the Earth. For now, let's stick with the Northern Hemisphere. And let's go at a latitude that's roughly similar to Westchester, about 41 degrees. How do I change from a celestial sphere view to a horizon diagram view? So what I'm going to do is I'm going to hit the switch button and it will change it to a horizon diagram view in this simulation. What will happen is that the view will zoom in to a person standing at that white dot. And because we are not standing at the North Pole of the Earth, when we zoom in, the person will turn right side up in the diagram, which will make the north celestial pole tilted in our view. So let me hit switch, and I'll do it a couple times so you can get a feel for how these two figures are related. We're zooming in on the person standing there on the Earth, and the celestial sphere is still around them. The blue lines represent the north and the south celestial poles, but we see that the horizon has been extended out so that we're really zoomed in on this person. I can move the view around so I can look at this person from almost any direction, but let me make it similar to what we have in our book horizon diagram. Remember, in our book horizon diagram, the north celestial pole is somewhere in the upper left portion of the diagram, which means that the northern horizon is over to the left. So if I were to look at this person completely from top down or overhead, north would be on the left, south would be over on the right, east would be at the top, and west would be on the bottom. But I'm looking at them from the side in the book diagram. So what that means is east is into the paper or into the screen, west is out of the paper or out of the screen, south is to the right, and north is to the left. If you were that person, you wouldn't see this. Remember, we're outside of the sphere or outside of the diagram looking in. Also, note something here. North is not straight up, and north is not directly to the left. The north celestial pole is not straight up, or it's not directly to the left. North is to the left. And also, keep in mind, south, the southern horizon direction, is not beneath us. When we talk about directions, we're always talking about directions on the horizon. So for this person, they would only see anything that's above their horizon. And that's where this concept of rising and setting comes in. All right, let me switch back to the celestial sphere view. And here we have the Earth surrounded by the celestial sphere. Also note that we have a yellow line here that appears to be the celestial equator because it roughly lines up with where Earth's equator would be. Now, if I switch back to our horizon view, a person standing there, we're zooming in, we make them right side up again, that yellow line could also represent the path of a star on the celestial sphere as it rotates around us. And notice that that line intersects with the eastern horizon the western horizon, and that will be important a little bit later. Alright, let's go back to the presentation just for a moment. And I want to tell you one more thing. If something is below the horizon,